Well, hello there. Back by, I would say moderate demand. Um, Here I am with another video for you on my channel. So now that I am a math influencer, I'm gonna get carried away with this. I think I need water. Let's go through this lesson together, shall we? Okay. This is inscribed angles 9.3 in honors geometry. So inscribed angles are what we see here. This is different than a central angle. A central angle would go through the center, point P, but this inscribed angle goes past the center. So if an inscribed angle is an angle, I don't know why that says if. An inscribed angle is an angle with its vertex on the circle with two sides that are chords. So there is that vertex on the circle, and then chord BA and chord BC. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So that would be arc AC. So I could put that there, arc AC. The degree of the inscribed angle is half the measure of its intercepted arc. So this is a formula that is going to be important for us as we continue to move forward. Okay. Then when we intercept a diameter, like we see here, if an inscribed angle intercepts a diameter, so the diameter being BC, now we have that inscribed angle BAC. If that happens, then it's a right angle, which makes sense because the semicircle would be 180 degrees. So that would be the intercepted arc, which would be 180 degrees, making angle A there a right angle. And then I just added a note. This will be important to solve right triangle trig problems within circles. So we'll see trig come back. We'll see the Pythagorean theorem come back because of that's a right angle. Because overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent. So the measure of angle ABD, so that's this angle, is going to be equal to the measure of angle ACD, that's this angle. And that's because they both intersect, are intercepting with arc AD. Okay, so you can trace that for yourself. Take a look at the endpoints, see what you notice there. All right, so now let's practice finding each angle and or arc measure. I'm so sorry, I'm drinking a seltzer and this is just disrupting me. Okay, so we have arc WY, it's right here. We want to find the measure of angle WXY, so that's in here. This is in inscribed angle, so that it has to be half of 62. So that'll be 31 degrees. Okay. So now we have the inscribed angle and we want the arc outside. So now we double the value of that inscribed angle. 2 times 113 will give me 226 degrees. Okay. And now this looks like the diameter. So since that's the diameter, I know that that's going to be 90 degrees because that's going to be half of the 180. All right, you can pause and try these on your own, or you can just keep listening to my beautiful voice. Whatever works. So we are looking for the measure of arc BC. So we're looking for this part. Right now we don't have enough information to figure that out, but we can get there. So if that's 47, in order to get the measure of the arc outside, I have to double the angle measure. So that's 94 degrees. Out here, since this is a diameter, this is 180 degrees. So then this is just going to be what's left from 360. So we would do 360, that's a 3, minus the sum of 180 and 94. and that'll be 86 degrees. Okay, the measure of angle JKL is what we're looking for here. So first I have to find out the measure of this arc, which I can. So that'll be 360, the total, minus the sum of 53 and 65. So that gives me 242, but that's not the measure of the angle, that's the measure of the arc. In order to get the angle, I have to do half of that. And that'll be 121 degrees. All right, this one looks a little trickier, but we totally got it. So we have the measure of all these arcs here. So we have this part, and this part. I would just add those all together and take from 360, and that would leave me with 82 degrees. Okay, now I'm looking for the measure, I'll do a different color, measure of angle RST. So that's this angle, and the measure of angle RUT, that angle. So they both intercept the same arc here. So if that arc is 82 degrees, and these are two inscribed angles, that means I have to do half of 82. And they're both going to be congruent because they intercept the same arc. So they would each be 41 degrees. Okay. All right, getting into a little bit of algebra here. Same idea. So we can do this two different ways. It'll kind of just depend on whether numbers or expressions are even or odd. So when I want to go, I can say that the measure of the inscribed angle equals half the measure of the arc, or the measure of the arc equals 2 times the measure of the inscribed angle. So we can use those interchangeably. So maybe I'll use one, maybe I'll use the other, depending on the problem. So we'll just kind of go with the flow. All right, so we want to solve for x. X is within an expression in number 7 in an inscribed angle. And then we're given the arc here. So I can say that the measure of the inscribed angle, 8x minus 9, equals half of 158. So the measure of the, I'm using that first equation, measure of the inscribed angle is half the measure of the arc. So I have 8x minus 9. Excuse me, I need to pause this. I don't know how to do that. Hello? I just got a scam call and I didn't know how to pause this, so I'm sorry that you sat through that with me, but I appreciate you. No, whatever. Anyway, so half of 158 is 79. Add 9 to both sides to get 88. And we're looking for x, that's our goal. X equals 11. Cool. All right, solve for x again. I have my inscribed angle. And I have my intersecting arc measure. So the measure of my inscribed angle is half the measure of its intercepting arc. So now I'm doing the algebra on, or the 1/2 of the algebraic expression. Doesn't matter which way I do that. This is just what I felt like. So I split that in half. Subtract 29 on both sides, 38. And I look for x, that's my goal, x equals 19. Boom, bam, bang. Logical. All right, the next problem, number 9. I noticed that WY is a diameter, so that means that angle X has to be a right angle. So I already know 13x minus 1 equals 90. So 13x equals 91. Therefore, I'm looking just for x equals 7. Okay. This one. Okay, so I have 78 degrees here. That's about it. I need to figure out over here what that number is. Okay, I know that this will be 114 times 2, so that's 228. And then I do 360 minus 78 plus 228. And get 54. So that's 54 here. So 54 is twice 7x minus 6. So I can say 7x, I'm sorry, plus 6 is half of 54. So 7x plus 6 is 27. So 7x is 21. X equals 3. That's all I'm looking for. There it is. Oh, that's a pause button. Huh. I don't know if I'm pausing it or not. How can I be sure? Oh, this is a bummer. Here's my little John. So it's recording. The best. Number 11. Same idea. Let's figure out the measure of the arc here. 360 minus 92 plus 162. That'll give us 106. And park. All right, this is our intercepting angle, or our inscribed angle. So 7x minus 10 equals half of 106. So 7x minus 10 equals 53. So 7x equals 63. And x equals 9. That's all we're looking for. This is fun, this last one, a little different. So here, our inscribed angle is 67 degrees. That means the measure of the intercepting arc is 134 degrees. And if I have these two parts, I can add and subtract from 360 to get 106 here. Again, 106. Wow, it keeps coming up. So 5x plus 21 equals 106. 5x equals 85. And x equals 17. That's great. So I just need to solve for x. All right, next one. Measure of, okay, so here's all algebra, so we have to label. So if the measure of angle FGH is 6x plus 21, and the measure of arc FJH is 17x minus 28, that's the arc, finds the measure of the major arc. All right. So I have to multiply my inscribed angle by 2. And set that equal to the measure of my arc. Again, we should be labeling our images. All right, and now we're just going to solve this equation. So we have 12x plus 42 equals 17x minus 28. So we'll get that to be 70 equals 5x. Therefore, 14 equals 5x. 14 equals just regular x, which is great, but now we want the measure of the arc. So the measure of major arc, FJH, is going to be 17 times the value of x minus 28. And we can put that in our calculator and get 210 degrees. So then maybe you can ask yourself, what's the measure of, or what are 2 different ways I can calculate the measure of angle FGH? Interesting. All right. If the measure of angle STU, so that inscribed angle, is 5x minus 16, and the measure of its minor arc that intercepts is 12x minus 50, find the measure of angle STU. So since that's even, I can take half of it. So I can say 5x minus 16 is equal to half of the arc. That'll give me smaller numbers to work with. So it might be in your best interest to do that too, but you would get the same answer either way. So now since that's 6x and 5x, I'm already almost there. And just bring my constants to one side, my x's to the other. Now I already have the value of x. Now I'm looking for the measure of angle STU. So the measure of angle STU is going to be 5 times 9 minus 16. 45 minus 16 will be 29 degrees. The measure of angle ABD is 6x plus 25. And the measure of angle ACD is 13x minus 9. Find the measure of arc AD. So since they are both inscribed angles with the same intercepting arc, that means I can set them equal to each other because they are congruent. So then that gives me 35 here, 7x here. So 5 equals x. And now I'm looking for the measure of the arc. I don't have an expression for that, but I can just double one of the inscribed angles. So it doesn't matter which one. Like the one that looks like it had smaller numbers, but I don't know if that's really the case. So 2 times the quantity of 6 times 5, 30, plus 26, 56 times 2, 112. All right, and then if the measure of angle KJL, so that's here, is 3x plus 2, and the measure of angle KLJ is 7x minus 32, finds the measure of arc KL. Okay, so it looks like we don't have enough information. I can't set those two equal to each other because they're not intercepting the same arc. This angle intercepts arc KL. This angle intercepts arc JK. But we do know, because this is the diameter, that this is going to be a right angle. And that means that these two angles are going to be complementary. So I'm going to add them up and set them equal to 90. So 3x plus 7 plus 7x minus 32 has to equal 90. So it's 10x minus 30. So 10x equals 120. Therefore, x equals 12. I want the measure of arc KL. So that is going to be twice 3 times 12 plus 2. So that's 36 plus 2 is 38 times 2 is 76 degrees. Okay? I'm having fun. I hope you are too. And then finally, inscribed quadrilaterals. I know we haven't really talked about quadrilaterals. We kind of skipped that chapter, but we're good now. So if a quadrilateral is inscribed, that means it's inside of a circle, then its opposite angles are supplementary. So not congruent, not whatever else you want to say. So A and C add up to 180, and we can say D and E. D and B add up to 180. So they are opposite angles, supplementary. Here we go. So we have to figure out what lines up with each other. Sometimes it's tricky. So K and M is what's across from that, and JL is across from that, if that's helpful. So really, we just have to do 180 minus each of them. So for angle J, we would do 180 minus 92 to give us 88 degrees. And for angle K, I would do 180 minus 45 to give me 135 degrees. All right, for angle 2, Q is across from S. Why am I hesitating on that? So Q's across from S. So I'll do that one first. 180 minus 93 to give me 87 degrees. Okay, so I have that. 90 is going to help us with something. Okay, so now angle S is this intercepts with arc PQR. So I would do 2 times 87, which is 174. Is it? 160 plus 14, 174. Then I do 174 minus 126 to get 48 here. Didn't pause, I'm just out here thinking in these streets. Okay. So let's get this arc, SR. So let's do 360 minus 90 minus 126 minus 48. It gives us 96 degrees here. All right. So now you want the measure of angle P. So that's going to be half of 48 plus 96, which will give us 72 degrees. And then measure of angle R, we would do 180 minus 72, get 108. Okay, number 3. W is probably the easiest one to find first. 180 minus 51. So that's across from Y. So we do that, we get 129. Now we have these other arcs to figure out. So if I do 51 times 2, that's 102. 102 minus 67 is 35. So 35 goes here. And then I do 360 minus 101 minus 67 minus 35 is 157 over here. So I just have to figure out, am I going to look for angle V or angle X first? This doesn't really matter. I guess X. So angle X is here. Intercepts, I'm drawing the whole angle. So now I see it intercepts with arc V, nope, YVW. So I'm going to add those up and divide by 2. So 101 plus 67 divided by 2, I get 84 degrees. And then the supplement to 84 degrees is 96 degrees. Number 4. Let's figure out what we're missing. We're missing that arc first. So let's do that. We could go from there. 360 minus 39 minus 61 minus 147 is 113. So it's 113 degrees here. So let's find angle D first. So it's going to be half of the sum of 39 and 61. So that's 50 degrees. Angle D is coupled with angle B. So that'll be 130 degrees. Is there a supplementary? And now we can look at angle A. So that is from B to D. So 61 plus 147. Half of that is 104. And then the supplement to 104 would be 76. Okay. So it looks like you got the hang of it. You can try these. Why not? It's up to you. I'm not going to do them. Appreciate you watching this. Appreciate you reaching out and telling me that this is important for you. Again, I apologize for not doing that ahead of time and not giving you warning. So if you need anything, remember to join the chat on Wednesday. Keep reaching out to me. It's really good to hear from you since I can't see you. What a bummer. Okay. Take care. Hope you're doing well. Talk to you later. Bye.